So when scientists look at stars, how can we know what elements there are? If we've never even been to a star, then how do we know that the nearby stars are made of the same stuff the sun is? Well, the reason we know is because we can study the light. In fact, the light from the stars is the only clue we have as to their composition. So let's take a look at an element. We'll turn the line intensity up so we can see these colors a bit better. What scientists do is we study hydrogen's absorption and emission spectra on Earth. And just to give you an idea, an absorption spectrum would be when light is going through a superheated gas. Then we use a lens plus diffraction grating to project the light onto the screen. This is called an absorption spectrum because the light is being absorbed by the gas, and as a result, the absorbed colors are not present on the screen. So absorption spectra is also called dark line spectrum. Emission spectrum on the top would be when I take the gas itself, and the gas itself is the light source instead of this external source. I run a bunch of electricity through the gas, then send it through a lens plus diffraction grating. And so only the emitted light shows up on the screen, giving us bright lines. And these correspond to each other, which you should notice. These correspond to each other because the same electron transition in the atom that causes the absorption of light also gets emitted. And since energy is conserved, those would have the same energy, thereby the same frequency, and therefore the same wavelength and color. So scientists would study hydrogen and helium on Earth, and when we look through a telescope at the stars, we can use diffraction gratings to look really closely at all these lines and not only determine the composition of stars, right, but we can use the composition of stars to backtrack and get their age. We could use the relative position of these to also get their movement towards or away from us, using basically the equivalent of a Doppler effect with light. Right? So let's take a look at a few other absorption and emission spectrums. One popular one would be sodium. See how sodium lights have these characteristic yellow-orange? These are actually very high intensity lines. So sodium lights used to be used throughout all of the US for nighttime, like lighting and things like that. And they would have this characteristic yellow-orange color in sodium lights. Simple atoms like hydrogen with only one electron will have simple spectral lines. The more complicated ones like uranium, plutonium, will have many, many more lines because think of it as it has many, many, many more electrons. Uranium has 92 electrons in its unionized state. So, to bring it back, all the different materials, all the different elements have unique spectral lines. Those spectral lines might be absorption or emission spectra, but those two sets of lines match with each other. The sets of lines are unique to each element, and so we can use them to determine what element is in a mixture.